Anderson Drilling is a world leader in the drilled shaft industry, specializing in the construction of deep foundation elements and the installation of earth retention systems. Along with our specialized and proprietary drilling equipment, state-of-the-art tooling, and our staff of seasoned project managers, engineers, and field support personnel, Anderson Drilling has the experience and the expertise to provide the best solution for any deep foundation or earth retention need. One of the most versatile, efficient, and economical deep foundation solutions is auger cast pile construction, which combines the advantages of driven piles with the adaptability of drilled shafts. Auger cast piles provide effective high-capacity deep foundation systems in a variety of subsurface conditions with differing geometries. The piles are formed by drilling into the soil with a hollow-stemmed continuous flight auger. A high-slump concrete mix is then pumped down the stem as the auger is slowly withdrawn, leaving a shaft of fluid concrete to ground level. Steel reinforcing is then typically inserted and lowered into the shaft while the cement ground is still fluid. The completed piles will commonly range from 18 inches to 30 inches in diameter and to a depth of 90 feet. Before drilling begins, soil test boreholes are drilled or augered into the ground in order to sample and classify subsurface conditions at intervals around the site. From these test borings, a geotechnical report is generated, which is used to determine the optimal pile diameters and drilling depths. The site is then surveyed and a plan is generated which indicates the accurate placement and depth of each pile. The position of all piles throughout the site will be located and precisely marked with the aid of laser-operated surveying equipment and GPS, or Global Positioning Satellite. Installation of auger cast piles is performed with Anderson's modern and diverse equipment fleet of specialized hydraulic drill rigs or conventional cranes outfitted with swinging leads. The equipment is highly mobile and quickly and easily moved into place. The auger is then positioned, centered precisely, and plumbed before drilling begins. At this particular site, a 50-foot continuous flight auger with a diameter of 24 inches is used to drill to a depth of approximately 55 feet. Advanced electronics and transducers fitted into the drilling equipment allow for constant real-time electronic data monitoring and recording of critical information such as auger rotation speed, depth, and torque, as well as constant control of flow pressure during concrete placement. This advanced quality control system assures pile integrity and consistency throughout the project. It also provides a data record of the entire installation, which can be stored and used for later evaluation by engineers, owners, and governing agencies. As drilling progresses, the soil at each drill hole can be visually inspected and tested. A change in the soil composition or resistance, as indicated by a change in the rotation speed of the auger, signifies that drilling has reached a layer of dense substrate, in this case at a depth of 55 feet. This can also be easily confirmed by readings on the electronic data monitor. At this site, the drilling is continued several feet deeper into this layer of denser substrate. When the required depth is reached, the auger is charged with the high slump concrete. Concrete flow begins as the auger is retracted slightly, just enough to allow a cap on the end of the auger's hollow stem to be sprung and hinged open. This high slump concrete mix is pumped through the stem under constant pressure as the auger is steadily lifted. The rate of concrete placement and auger withdrawal from the soil are dependent on soil conditions and equipment capability, and they are coordinated to maintain a positive head pressure at all times. This process leaves a shaft of fluid concrete that fills the voids left by the auger inside the pile, expanding its diameter and also compacting and consolidating weak soil zones. When the concreting operation is complete, steel reinforcing is typically inserted and lowered into the shaft while the cement grout is still fluid, effectively casting it into place with the pile. A variety of shaft reinforcing options are available. A modified rebar cage is most commonly used, and cage configurations may vary depending on load design requirements. Small plastic wheels are attached at various points along the cage perimeter, which help to center it in the shaft as it is lowered into the liquid grout. In addition, a single steel rod with a centralizer attached extends downward from the middle of the cage, nearly reaching the bottom of the shaft, completing the auger cast pile element. Once all of the auger cast piles have been installed, they're typically tied together with a reinforced concrete slab. This completes the structure's deep foundation system. Auger cast pile construction has a number of distinct advantages. The drilling method can be used in a wide variety of soils, dry or saturated, loose or cohesive. The installation method, utilizing a full-length auger as both the excavation tool and the concrete placement conduit, eliminates the need for shaft stabilization during construction. The lateral pressures produced during the pumping of the concrete used to fill the shaft exceed the pressures of the surrounding soil, maintaining shaft integrity and developing excellent skin friction. Installation of auger cast-in-place piles is performed without the detrimental shock, vibration, or hammer noise typically associated with driven piles, which means it can usually be installed with minimal disturbance to adjacent footings or existing structures, thus making it the most convenient method for construction in urban centers. Auger cast piles also have a high axial load capacity. And finally, the efficient and relatively fast installation of auger cast piles leads to high productivity. This has been a presentation of Anderson Drilling, world leaders in deep foundation construction.